Okay. Okay, as usual, like just talk a lot. I don't want to talk a lot. Carl starts with N cards labeled 1 to N, lined up in a random order on his desk. He got a pair of these cards swapped if A is greater than B and A is left of B. For instance, the sequence 3142, there's three swaps, 3-1, 3-4, and 4-2. Okay, so what he does is you pick up the card labeled 1 and insert it back into the sequence in the opposite position. So since 1 is in like the second from left, you want to insert it so the second from right, keeping everything as the same. And you do the same thing with 2. So you pick up 2 and insert it over here. So uh sorry, 2 goes here. So this becomes this. You do the same thing with 3, then you do the same thing with 4. And the claim is that no matter what lineup of cards you start off with, the final lineup will have the same number of swap pairs as the starting lineup. Feels induction-y. Okay, okay. What are the other feels people are getting?
We
What
have
are
to
the
do this process
ideas?
for each of the cards from 1 to N.
Yes, you start from 1 and then 2, 1 to N in that order. Let us assume N is at the ith position. Okay. What are you inducting on, Shreyan? What are the ideas? Any other ideas? What are people feeling about this?
Somewhere I just feel like is that theorem Erdos-Zekers theorem. I don't know how is it pronounced.
Amazing. Wait, I have a tendency to forget things. What is the theorem?
It's in a sequence of n numbers. There is uh, wait. I don't remember the formal definition. It has something to do with increasing and decreasing subsequences.
Is it this one where if you have a sequence of mn plus 1, either there's a increasing subsequence of m plus 1 or decreasing of n plus 1 or something like that, right?
Yeah, yeah.
Okay, okay. How will that relate here? Interesting.
Hmm.
Hmm. What are some other ideas? What should we do? How do we proceed?
Just base cases.
Base cases, sure. What do you want to try? N equal to? Yeah, n equal to 1 is easy. N equal to 2 also. 1, 2, you just end up with you swap 1, swap 2, you end up with 1, 2. 2, 1 also, you end up with 2, 1. So it's the same thing. Sure. What happens for 3? Has anybody worked this out?
Could you just scroll up a bit? I'll take a quick screenshot of the problem.
Sure, sure.
Yeah.
Speak up, speak up, speak up. So what happens for 1, 2, 3? You end up with 1, 2, 3 again.
Yeah, it just
Are
goes
there
to 1 to
any?
3.
Sorry.
Yeah, it
Say
just
that
goes to
again,
1 to 3.
Nishan.
I was going to say that it
Yes,
was
okay.
1 to 3.
Sure, sure, sure. Okay, tell me more. What should I do more?
I mean, it's holding, but I don't see any, like, okay.
Yeah, like there's no addition to gain from what you've done so far. Do you want to do more cases?
What about
Sorry, say that again.
like checking the number of how the number of swapped pairs changes as we like do this process once?
Right, right. Okay, so this is also known as the number of inversions. So a pair, like a swap pair is also known as inversion. So we can just refer to it as an inversion. Okay, so the idea is to look at how the number of inversions is changing throughout the process, right? So we start off with the 3142. This has how many? 3. What happens when we switch the place of 1? Um, Counting is hard. Somebody do this. 1. No, this is not an inversion.
That's
This
not
is
an
an
inversion.
inversion. This is an inversion. This is an inversion. This is an inversion. 4. Okay. Then we have 2, 3, 4, 1. What happens here? Hmm,
3.
I will believe you on that. Then we have 2, 4, 3, 1.
I think 4 again.
4, yeah.
Okay. Interesting. Are there any preliminary or seemingly stupid observations or like any observations at all about anything?
It just alternates, but that's most likely not going to hold.
Sure. Anything else? That is easy to see why it holds. How about okay. What happens if we start with 1, 2, 3, 4? What do we end up with?
But isn't that already ordered? So do you have to do anything more? I'm not quite understanding. You're saying that 1, 2, 3, 4 is your beginning set of cards.
Yes.
But
Yes.
if that's already ordered, do you need to do
And
anything?
there's nothing about being ordered. Like no matter what you start with, you start by taking 1 and changing its place, then changing the place of 2, changing the place of 3, and so on.
Oh, so it doesn't matter what your initial condition is. You have to, in the end, get an ordered thing.
No, no, no. There's nothing about orders anywhere. So you start off with some sequence, then you pick up the card labeled 1 and then put it so that it's like mirror image. So if 1 was in the second place from the left, you put it so that it's second place from the right. Then you do the same thing
Yes.
with 2. Then you do the same thing with 3 and so on.
So you would have to do this until it's in ascending order. 1, 2, 3, 4.
No, no, no. You just do it once for 1, once for 2, once for 3, once for 4.
Okay. Okay. Yeah.
Yeah, and then you have to show that the number of inversions at the start is the same as number of inversions at the end. Yes, 1, 2, 3, 4 does not
Repeat
have
that
any
last
swap
part.
pair, but you have to show that the number of. Okay, so do you understand swapped pair is?
Yeah.
Just rotation, right? Like if you just clockwise rotate.
And then you end up with 1, 2, 3, 4 at the end. So that's for 1, 2, 3, 4, it's trivially true that the number of inversions you started off with is the same as number of inversions you're ending up with. Right?
Yeah.
So any like generalized preliminary observations that you want to make? Shreya, they want to unmute and explain your idea. Okay. What are people talk? People talk. I don't know what to talk if you guys don't talk. What are you thinking? Is the question completely clear to everybody? I hope it is.
Yeah.
Okay. So how do we deal with this? Right?
I was like thinking of like
Hmm.
writing it in like a half fashion, like you write the first half and you write the second half below it in reverse.
Okay. How will that why will that help? And like why are you doing that? Sounds like
Because
an
we are
interesting
like
idea.
kind of like just swapping it like, okay, wait. Is that how it's supposed to look? Wait, which case are we taking?
3, 1, 4, 2.
Yeah, this one. So, an inversion, I mean, the process just becomes like swapping the top and the bottom element. So it's easier to see, I guess.
Hmm. Okay, interesting idea. Okay. Hmm. The first you're swapping 1, then you're swapping 2, then you're swapping 3, and then you're swapping 4. Interesting. I don't think that's entirely how it's working. It's not entirely swapping, right? Because when you go from 3, 4, 1, 2 to 2, 3, 4, 1, that's not how it's happening. Or is it? Like you have 3, 4, 2, 1, you're swapping like this, right? So you're not swapping 2 and 3 here. You're just taking 2 and placing it here.
Yeah, that's what I
So
meant.
3 is
Like
not
you,
going. Hmm.
that, like that cell goes to the top of cell and top cell goes down.
No. The top cell is not going down. Like this is becoming 2, 3, 4, 1.
I
2
meant
and
like
3 are not getting swapped.
in each step that we do it, that's the only thing that's happening.
So you're starting off. So I'm saying, look at this step, going from 3, 4, 1, 2 to 2, 3, 4, 1.
Correct.
So what is happening is you're swapping the two. So you're saying that this 2 and this 3 should like switch places, right?
Yes. Oh wait, did I make a mistake? One
Uh,
second.
yeah, that's not what's happening here. That was an interesting idea, nonetheless. Something to think about.
I'm still not quite understanding what that last line's meaning, where you have the same number of swapped pairs as the starting lineup. Since everything's every element is assigned another one, which is opposite to it, kind of like if you reflect it from the middle. So, what exactly is how can you have a different number of swapped pairs to begin with?
I mean, it's not obvious why you would have the same number of swap pairs, right? Like when you remove something and putting it somewhere else, the number of swap pairs is changing in an unpredictable manner.
Okay, so how do we define swapped pairs again? Would it just be like for the 3 1 4 2, one
Yeah.
four is a 1 4 is a pair and 3 2 is a pair.
No, so there are 6 pairs in 3 1 4 2, out of which we have 3 1 3 2 and 4 2 as swapped. Basically, think of them as things in like descending order. Just like pairs which are in descending order, that's a swap pair.
Oh yes, okay. So okay, yeah, now I
Yeah.
see.
Yeah. So the thing about this is like this process is very hard to sort of model in the sense that it's quite random. Like what are you doing? Like putting like removing this one entirely and putting it somewhere else. So it's a good attempt at understanding this better, but it doesn't seem to work out. There are any other ideas to understand it better?
Yeah, because the process is not repetitive that much. So we can't
Hmm.
exactly future plan it.
Yeah,
Maybe a circle,
interesting. So you're saying we start off in a circle, and then what do we do?
and then we like do the process. So, well, let me just work it out 1 second, the details.
Sure, sure. Okay, so when I see this problem, there's like a couple of different approaches that are coming to my mind. Um, okay, so firstly, some seemingly stupid observations is firstly, if you start off with 1 to n in an ascending order, you're going to end with 1 to n in ascending order. Like the
Isn't
process
that
at the
just
end will give you this. Yeah, that's a
isn't that just
stupid
rotating?
observation. Exactly.
Aren't you
So
just
every step.
rotating?
No. So what's happening is like you have to flip every single object, every single number from 1 to n. So you start off by flipping 1, then you flip 2, then you flip 3. So it all just like cyclically rotates and gets back to 1 to n at the end. So when you start off with 1 to n, you end with 1 to n. So obviously the invergence is going to be the same for distance. Right? Is
Yes.
that fair? Yes, okay. Yeah, that's fair. Okay. And maybe like some wishful thinking that I want to do here is okay. This process is incredibly weird. Like I am not able to see any nice way to sort of formalize it or do nice things with it. Is there some way where I can so like again, this seems like some invariant monovariant kind of a thing, right? Maybe if I can find some invariant in this process where I can somehow say that okay, this is constant, so by the end of it, this will also like be the same. Something along those lines, if I can do, where I can like examine every step of the process and observe that okay, this is something that is not changing throughout. That'll be nice. So, so the thing to hope for is some sort of an invariant. Hmm. Interesting. Invariant, which is like not changing throughout the process, not just at the beginning and the end.
Okay, a trivial one would be that if you have an odd number of terms, then the middle term doesn't change at all.
Not true. For example, if you're starting off with 1, 3, 2, then you flip this one goes here, so you get 3, 2, 1. So now earlier the middle term was 3, now it's 2.
Oh, okay. Now I thought that okay, yeah, I thought that whenever you flip the one, you have to flip the two also on the other side. Okay, yeah.
Hmm. So for some reason, my Zoom chat is glitching a lot, so I can't see anything on the side. Like it's not allowing me to scroll down. It's just like stuck at one point. I don't know. So if you want to say something, just please unmute and say because I am not able to follow the chat. I don't know why it's hanging. Um, yes. So we're looking for an invariance is not changing throughout. And okay, any other observations? Maybe from trying some small cases that you might have.
So if it's an invariant, it has to not change based on some other thing, right? So as in that you have a property and it won't change for this kind of event. So like you can say for some generalized thing, if you have one number, it does not
Hmm.
change its place
Hmm.
when you go. So invariancy should be against something. kind of.
Yeah. So like I'm saying, like we're hoping to find some invariant which is like which is not changing throughout this process. Like when I flip the one, I can be sure that okay, this invariant is like not changed. Then I flip the two, and then I can be sure okay, this invariant has not changed. So on and so forth. If that makes sense.
Okay.
Guys, I can see that messages are coming in the chat, but it's so weird because I am just not able to see what the messages are. I don't know how to fix this issue. Ah, okay, now I see it. Okay. A circle not working, I tried. Okay. Sad. Okay. Any other ideas? Okay, how about are there any other sequences that are not changing? Like 1 to n, if you start off with it's not going to change. Is there anything else like that that's not changing? Any other observations or hopes from the problem?
Like, does the descending sequence not change?
Interesting. What happens if you start off with n minus 1 up till 1? Yes, exactly. Actually, Anne points out again, like you will just that will just be like the exact opposite. So the one will go here, then two will go here, three will go here, and at the end you'll end up with the exact same thing.
I think like any cyclic arrangement goes to the same cyclic arrangement.
Really interesting. So what happens if you start with 2, 3, 1? Would that make sense though? Try to think about it because that would have to mean that the two cyclic arrangements have the same number of inversions.
Wait, let
So
me just figure it out.
so if you start, yeah, we can do it together. So if you start with 2, 3, 1, what happens if one gets flipped to 1, 2, 3, then two stays same, and then three gets flipped to 3, 1, 2. Okay, that seems to be working. How about we
Oh,
start with
so cycle
three,
goes to
one,
cycle.
two? I don't know, maybe. How would we do that? Wait, one stays there, then two flips. Hmm. Does it still hold for 4 also? 2, 3, 4, 1. Maybe 1, 3, 4, 1, 2. You flip 1, then you flip 2, then you flip 3. And yeah, this does not seem to work. See, sorry. If I've done this thing properly,
Wait, what
then
was the thing you did after the second step? After 3142?
I removed 2 and placed it here.
Okay.
Yeah. Hmm. Okay, so basically you're composing n rotations onto a permutation all around the center. Interesting way to think about it. Okay. What is like one stupid invariant? Like just from while we go from here to here. Like we take the one and then we change its position to somewhere. But there is some like we're not just randomly putting the one anywhere. We are putting it in another place in some specific manner, right? So what is like an invariant in that step? Like it's like a very stupid kind of a question. Um, what did not change? Like in what way, in what nice way are we removing the one and placing it again? There's something that is not changing when we are doing this. Like some quantity that we are referring to.
Wait, could you repeat your question again?
I'm just saying like there is something like maybe in general for the first and the last it's not true. But going from 314 to 3412, we are removing the one and placing it in some specific way. So what is that specific? Yes. Position before and position after congruent mod n. Not really. So the position here was 2, and then now the position here is 3.
Is it right in saying
But
like
mhm. No, say it.
like all the numbers before the one like will be a inversion because that number
Yes,
and the one
exactly.
will be
That's a great observation. So observation, all numbers
and
before
for n
one
it will be in
contribute.
reverse, I guess.
Exactly. Amazing. All numbers before one. And I don't want to say one. I'll say all numbers before the smallest number in the sequence, right?
Okay. But one is the smallest
Contribute
number.
to. Yes. But I just want to say it this way because
Okay,
like I
very
just
good.
want to think generally. Yeah. Means will contribute to will contribute to an inversion with one.
Wait, so can we just like ignore one like after that? I don't know.
Wait. And also another thing you said is for n it's the exact opposite, right? For the
Yes.
largest number, for the largest, all numbers after all numbers after contribute. Wow, okay. I'll be surprised if anybody can actually like read what I'm writing. It just looks like noodles to me after written it. But anyways, contribute to
What
it.
what
Ah,
what is
but
an inversion?
inversion is just a swap pair.
Okay.
So I'm just referring to an inversion and a swap pair. Yeah, this makes sense. Does this make sense? Okay. All right. But now the cool thing is like initially one was here. So everything here was this. And now we are placing one somewhere so that the number of numbers earlier that were before one is the number of numbers that is after one. Do you sort of see where this is maybe going? I don't know.
N minus I? I don't know. Right.
So it's like one nice thing that's not changing. So one nice thing that is not changing here is like the number of numbers that were there before one are the number of numbers after one now. And that is very cool. That is very, very important because that just kind of, yeah, that's like a very big thing. Don't forget that. And also we just did this. We just claimed that if we have the smallest number, then everything before it contributes. And if we have the biggest number, then everything after it contributes to the inversion. So can we do something nice by which at every step the number of inversions is not changing? Does that make sense? Does it make sense what I'm saying, or does it sound like nonsense?
So we're talking about the first step itself that this holds, right?
Yes. For now, just think about the first step. Like, if we could do something to the, like, okay, now I'm just
Are
saying
we
too
going to
much.
talk generally now, or are we going to talk about the first step
No,
only?
just for the first step. Just look at the first step. You're taking one, you're placing it somewhere so that the number of numbers before one is now the number of numbers after one.
So you can just make it the largest number. You can add something to it.
Amazing. Exactly, exactly. Does that make sense? If we don't want the number of numbers to change, number of inversions to change, we can just make the one the largest number, and the number of inversions will still be the same.
Okay, so you need to add something greater than n, greater than or equal to n. If
Right.
n is the number of thing.
So just add
Yes.
n because that's
Sure.
down.
Let's try doing that. Exactly. So we start with 3142. Then we place one here, but while placing it there, we just make it 1 plus 4 and just like make it 5, let's say, because we want to make
Okay,
it
so
the
we're using
largest.
n here.
Huh, sure. Let's use n because on the shant side, just use n. Why not? Okay, what do we do next now? Now we have to flip 2.
Do the same
Yeah,
for two,
so
I guess.
then you get 6345.
Exactly. 6345. Now you have to flip 3. And observe, like, the very neat thing here is every time the number you're flipping is going to be the least number,
Yeah.
which means that every single step, your inversions, number of inversions is not going to change.
Okay,
So can you, yes, exactly. Huh.
then we get 6475.
6, 4, I'll just believe you and write what you're saying. Huh?
Yeah,
And
and
then,
then okay, what would this be? 6785.
exactly. And then you end up with 6785.
Oh yeah, since now you've done a swap, you've swapped for every one of them, you can just remove by n. You get 2341.
Amazing, exactly. So you subtract 4 from all of these and you end up with 2, 3, 4, 1. And since we are not actually concerned about the actual numbers, the only thing we're concerned about is the ordering. So
Yeah.
6, 7, 8,
Yeah.
5, and 2, 3, 4, 1 are like the same ordering. So obviously the number of inversions is going to be equal. This problem and the solution just makes me so happy. So neat.
Okay, that was revealing. No, relieving. Yeah.
Yeah, one time I said call the midpoints MA, MB, MC respectfully instead of respectively, and I'm like still trolled for that. Yes.
Yeah, like revealing and revealing. Okay, relief. Yeah, really. Yeah, okay, I said it right.
Yeah. Anyways, this is very cool. I don't know if you found it cool, but like when I saw this, I was just like blown. Also, like if you directly see the solution, you're just like, what? Where is this plus n coming from? That makes no sense whatsoever.
So this is the
But
actual solution.
yes, yes, yes. This is the solution, and it works. There's actually more. There's so many nice other solutions. If you want, we can talk about them as well. This is the most magical one that I found. The other ones I found equally magical, but this one is just like one line. You just observe that you have to add n, and that just like finishes. There's nothing to do.
Yeah. Is this
Huh.
doing adding n and swapping? Is this perhaps some kind of kind of like a function we're adding on this sequence?
Huh, sure. So you can say that every time you swap, you must also add n. And then once everything is done, your resulting sequence is just going to be everything plus n. So the number of inversions in both the resulting sequences has to be equal. But also since each step, the number of inversions wasn't changing, the number of inversions at the end must also have not changed. Okay, what are people thinking about this? Like, I don't know. Did you also find this a happy problem, or
Like,
was
are
it
you
a
sure it's
meh
not
problem?
changing, or just like going to n minus I? Like if the I inversions, then n minus I.
Huh? Sorry, ask the question
One.
again.
Wait,
No,
so
then n plus I. For every I, you're changing it to n plus I.
Yeah, you're adding n because you want it to become the largest now.
no, I was talking about the number
When
of inversions, not the number
huh,
itself.
number of inversions in each step is not changing, no. So at the end, whatever sequence you have, the number of inversions is going to be the same as whatever you had in the beginning. Because in each step it's not changing. But the number of inversions, like the number of inversions is 6, 7, 8, 5, is going to be the same as the ones in 2, 3, 4, 1. Because the actual numbers is not what we're looking for, it's the ordering. So if and both of these sequences have the same ordering. That's the intuition. Right? Do you sort of see that, or do you want me to elaborate? I don't mind elaborating.
I just want you to like prove like the number of inversions stay same like throughout this process.
Throughout the process. So this is again like we just used your observations of smallest number, everything left to the left of smallest number contributes to the inversions, and everything to the right of the largest number contributes to the inversion. So what we want to do is when we're swapping one, the number of numbers before one is the same as the number of numbers after one, right? That's the way we are swapping it.
Correct.
So if we make one the largest number in the sequence, so if I make it 5, the number of inversions is not going to change because originally one was
Okay.
contributing one inversion, and now it's become 5, so it's contributing one inversion still.
Okay, yes, I got it. Yes. Thanks.
No worries. And now the nice thing is that since you've changed one, 2 is the least element. And then when you flip 2, then you make it the largest element. So it keeps working. Which I find is very, very neat.
Okay, so that's why you like insisted on smallest element instead of just one.
Exactly. So you end up with something where I know, right? It's crazy. I was like, I've every time I'm like a little sad, I think about this problem and just be happy. But yeah, this is like pretty cool. So you and also okay, and just to like repeat, so you end up with this exact sequence, but everything is added like +4. But the number of inversions in both of these is going to be the same because all the numbers have been increased by 4. So if 2 was less than 4 earlier, 6 is going to be less than 8. So the ordering has not changed. The number of inversions is still the same.
That
That was
problem
quite
proposer
great.
took a big risk.
Yes, this is the source of this is USA GMO 2018 P6, I think.
Oh,
Okay, there's some more cool solutions that we can discuss. For example, so first you observe some things like if you're starting off with 1 to n, you end up with 1 to n. And maybe you try to see how two sort of related sequences are going through the process. So, for example, one preliminary, like one sort of nice thing, which is also not too hard to see or prove, is if you start off with two sequences which are exact reverses of each other, then every step, whatever you do, it's going to be exact reverse of each other. And so something like that. So now you're trying to again think about two different sequences and them relating in some way and how at each step it's affecting this process is affecting them. That is another way to think about it. And this actually leads you to an entirely different solution. So okay, we'll just so what happens when you
So can
okay
we do
so
can,
yeah.
can we do something this is a bijection, right? This whole procedure is a bijection, right?
What do you mean? What do you mean?
I mean, if we start off with something, we know what we started with. If we know the output, we know the input, and vice versa.
Sure, yes.
So what we can just do is we can induct from the number of starting inversions. So like we can say that if we are finished for, and we just have to show that and it can't increase, and then we are done.
How would we go about doing that? Okay, so another cool thing, okay, maybe let's think about that. Another cool thing is, okay, so I'm working on inversion. What happens if you swap two adjacent elements? What happens to the total number of inversions? You keep everything else the same, but you pick some two adjacent elements and swap them. What happens to the number of inversions when two adjacent elements are swapped? Yes, exactly. Either it increases by one or decreases by one. So that's very neat. And maybe also, let's not discuss this in class, but this also leads to a very cool solution where you observe two sequences which are like one adjacent swap away and try to see how the process works for that. There's like some very cool, insanely cool stuff that you get, but maybe I'll just leave it for you to think about. Work it out. It's not hard, I know you can do it. So basically, what you should do is try to take two sequences, which are just like one adjacent swap away, and work out the process. And there's some nice observation you get, and that try to finish the problem from there. So the cool thing about, okay, something more you might want to know is the nice thing about adjacent swaps is that you can start off with any sequence, and just with some number of adjacent swaps, you can reach any other sequence you want. In particular, you can sort the numbers, so you can end up with 1, 2, 3 up till n. If you start off with any sequence just by swapping adjacent elements, you can end up with this. Okay. That's all about this problem. There's actually some more multiple solutions. You should definitely check out the AOPS. There's another very cool invariant which is also like very magical. Basically, what you look at is say once you're starting off, what you want to do is again try to get some quantity for which, or like maybe look at something where so that the number of inversions is not changing. So if you look at 3, 4, 1, 2, its inversions is like number of inversions there is clearly like not equal to 3. But if you look at 2, 3, 4, 1, this has 3 inversions, which is the same as 3, 1, 4, 2. So all I've done here is subtracted one, but from 1 I can't subtract 1, so I've just subtracted 1 mod 4 in some sense and subtracted 1. Now over here also, let's say I have 2, 3, 4, 1. So what can I do sort of to, okay, 2, 3, 4, 1 is still the same. Then maybe 2, 4, 3, 1. So there's some solution along these lines as well, where you magically sort of subtract some constant quantity from everything, and it turns out that the number of inversions for that quantity is not changing throughout. And that I found to be quite magical, and for that I don't know how to really motivate that, and you just have to sort of do a lot of cases and see it maybe.
What was the
Okay.
thing that did not change? What was the invariant?
So if you're looking at if this is the first step, then you subtract 1 from everything mod n. If it's the second step, then you subtract
That's the
2
same
from
thing
everything mod n.
That's the basic, that's for all purposes the same thing as what you did at the end. That's for all purposes the same thing as what we did now.
Wait, how? I don't see that.
I mean, by subtracting everything by 1 mod n, we are just taking
Ha
1
ha,
from
okay,
0.
sure.
Because-
Yes,
Yeah, I mean,
yeah. Ha, sure.
it
ठीक
feels like
है.
the same thing at the very least.
I think I see. So you're saying ki,
Yeah.
sure.
Instead of just adding at one point, just subtracting that from everything else, basically.
I see. Maybe it's not that straightforward, but maybe sort of feels like it. Sure. Let's go with
Yeah.
feels like it.
Yes.
Sure. But yeah, this is definitely a problem that's been like my
You-
favorite in the
You
recent
have to start
times.
off with 0
Okay.
though. But in that case, you would have to start off with 0, right? Not with 1. Do they start off with 0 or do they start off with 1?
No, you start with 1.
I mean the proof using that other invariant. Because if you started off with 0 using that other invariant, this would be equivalent.
So like the invariant is basically if you're after swapping I, then you subtract I from everything and mod n, and that keeps the number of inversions the same. That's the thing.
I minus 1 or I?
I. You're not starting with 0. Like 0 is for this, and 1 is for this, 2 is for this, 3 is for this, and so on.
Oh, okay. Then that would work. That would work.
Huh. Sure. Okay. Shall we move on to another question? Any further comments or questions about this? On a scale of 1 to 10, how happy did this problem make you?
9.
Okay, I'll take that. 8. Okay.
Oh,
-1? No, that has made me sad. This is so neat. And it's like, okay, Nishant, you made the actual observations that we used to solve it. So what is this behavior?
I thought about the observation in the beginning and I thought it was too useless, so I threw it away.
No,
Till the end.
never do that. Never do that. So that's what I was saying. Like any stupid observations you have is like going to be very helpful. Okay. All right.
it's like
Let's
the problem
huh?
curators know you need stupid arguments, otherwise you won't get it.
Like, okay, I'm just saying stupid, but they're not actually like stupid, okay? They're like very good observations because that's what led you to solving the problem. 3 on a
Yeah,
scale
like
of 5. Okay.
unwordly. Unwordly is better. You don't
Huh,
think of
sure.
it.
Yeah, exactly. It's quite neat. And these types of problems are like nice to look at after contest. Like you probably don't want such type of problems in a contest that you're giving.
But after contest, like if you don't solve it in the contest, like won't you get like disappointed with yourself, like after the contest?
Exactly. Like this problem, you pray that this kind of problem does not come in contest because it can be disheartening. Unless you solve it in contest, then it's like very, then it'll make you like insanely happy. Then it'll make me insanely happy. Okay. This is the next problem we're going to try. Has anybody seen this before?
No, I don't think so.
Okay. Yeah, this is another one of those problems that I was like, ooh, magic. But hopefully we will try to sort of motivate. Why is the triangle tilted? I will try
Wait, is
better.
this clean screen glitching or like are you just like moving it really fast?
No, I think it's randomly just scrolling up for some reason. I think it doesn't want to leave that earlier problem. No, Geo. Hey, Geo is nice now. Okay. This is E. Damn, I'm quite proud of how this diagram is going so far. D is this. We have DM, DN. Okay, what is M and N? B, D, and C. This is M. This is N. D is E, F, M, cap, E, N. Oh my God, this is a horrible diagram. Sorry about that. But I tried my best in my defense. D, E, T, F are given to be concyclic. So D, E, T, F given to be concyclic. Let's assume that's a circle. Through that DT passes through O. Through that DOT. Wow, what a problem. Okay, any preliminary observations?
Oh, we are given DTEF cyclic. D whatever.
Yes, yes, DETF is cyclic. That's given.
Midpoint of CD feels a bit random, but okay.
Yeah, CD and
Yeah, these
BD.
midpoints feel okay. Those are great observations. DB, DC seem random. Very good. Anything else? Do you know what the circle DEF is?
I mean, D is the center of AEF, so how do you want to define it?
Okay. D is center of AEF. Okay, good observation. D is center of AEF. Hmm. And somehow O wants to come into the picture for some reason. Somehow.
O as in the circumcenter of
ABC,
ABC.
ABC. Yes, O is ABC का center.
Yeah,
I'm not going to make
every
this
time I see an
simple.
orthocenter, I feel like draw the circumcircle and invert it, like reflected from BC.
Interesting.
But the point is that since D is the midpoint, it won't exactly help.
Yes, that does seem quite weird. So O
We
is
make,
going to be like somewhere here, maybe. Ah, yes, Nishan.
would we like make E and F midpoints? I don't know.
How? Make E and F midpoints of what?
I don't know,
Or
like
like
because
extend DE like this?
no, I'm just wait. How to explain
Okay.
it? Like maybe make CE construct some points such that on the other side of like on the side of A, like A dash E
Like
is equal to
this.
CE. I mean, I think it's
Okay.
random, but okay.
Okay. And then why? What is like the motivation? Or is it
Because there
just
are
like
like
the
more
same?
there are midpoints
Hmm.
and then like midpoints, some more midpoints. So like midpoint.
Yes. More midpoints is a great idea. So try to make more things midpoints. I like that idea.
I was
Also, like
thinking
we have some kind of centers as well. Like we know D is center of AEF and O is
AF.
center of ABC. Is there like some nice relationship between those two things?
Which two? Which two again?
Like D is center of AEF and O is
Yeah.
center of ABC.
Radical axis? No.
Hmm. Wait, what do you know about AEF?
Could it be internally tangent to the circumcircle of ABC?
That's not true. That's a well-known fact. So AEF is actually intersects ABC at something called
Viewpoint.
the Q point. Yes.
Yeah, oh, thank goodness.
All right.
Hmm.
Wait, we need to keep DETF cyclic, whatever we do.
What do you mean AEF intersects ABC?
No, just
AEF.
like
The circles, the circles.
I was
Oh,
thinking the Q point
Circles.
doesn't exist for a moment, so
Q. I'm quite proud of that joke. Okay.
What if we take like a homothety at H
Homogeneity at H.
of like 2?
Interesting. Okay. But then like still this okay, HB will go to some weird thing. Maybe
No,
you
like
actually
only
want
like
to.
DETF. Like we'll send it somewhere. Oh
DETF
yeah,
send it
DEF will land
somewhere.
the circumcircle, right? DEF, if you do homothety 2, like
Hmm.
all those 3 points land the
Yes.
circumcircle. So T also must lie in the
Yes.
circumcircle,
Okay. Okay, good
which
idea. My
means
diagram is like kind of scuffed for that. T looks like it's like lies on ABC at this point. Let me try to quickly sort of.
wait, so but DEF
Uh,
then just goes to the circumcircle of ABC, right? Unless I'm
yeah,
tripping.
yeah. You're not tripping. So maybe I should go. Have any of you heard of a circle that passes through the midpoint of AH ever?
Wait, is it BFEC? No.
okay, I think maybe there's a BMO problem on that, but no.
Ari, this is like, I think y'all are overthinking this. I think y'all know this.
Oh,
but y'all are
9-point circle.
overthinking.
Oh shit.
Thank you.
Um,
Why do I suck at all?
Yes.
This is a forehead smacking time.
Yes.
Like if
Oh wait,
everyone
yeah,
was
I
in an
just sends
audience, you
it to
would hear a
9-point
big
circle.
clap.
No, I do not want to. I do not condone any self-hurt. Let's do not do that. Okay, 9-point circle. Sure.
Okay,
So
then you
DEF
get
is the
some more
9-point circle.
points.
Wait, T lies on the
Hmm.
9-point circle.
Yeah.
Okay, that's why it makes sense to do the homothety, but okay,
Hmm.
still not a big difference.
Hmm. Is there any nice angles we know or something?
Okay, we could do some cyclicity, directed
Yeah, yeah.
angles.
Hmm.
what was
Do we
9-point
know
circle?
anything? Oh, 9-point circle is the circle that passes through the 9 points of a triangle, basically the 3 feet of altitudes, the 3 midpoints of sides, and 3 midpoints of like AH, BH, CH.
Yeah, very cool stuff.
Yes.
Wait, so what will T become on the 9-point circle with reference to DEF?
Yeah,
Become as in
that's quite weird to look at. Hmm.
I don't know what 9-point circle is, but assuming it is true, won't it just intersects midpoint of DC? Matlab ki, if we take perpendicular bisector of DC, it will passes through midpoint center of midpoint 9-point circle.
No. So how will perpendicular bisector of BC pass through center of 9-point circle?
Isn't that definition?
No. The better way to think about the 9-point circle is just take a homothety centered at H of ratio half. And the circumcircle ABC goes to the 9-point circle. Like A
Oh,
will go to D. That's like the quick 1 minute proof of it. That's all there is. This will go to the altitude, feet of altitude. This point will go to like the midpoint and so on.
Antipode. I think it will go soon.
Yeah.
mm.
Okay. What else? What else can we do? Like we know, like there is a gut feeling that we have to introduce some new midpoint, but what will be
What
the
about
nicest
midpoint of BC?
midpoint of BC? Interesting.
I mean, that
Somewhere
sounds
here.
not useful, but okay. Because O
Hmm.
is perpendicular to BC. I mean, OM is
Hmm.
perpendicular to BC. I mean, what do you call that midpoint now? A dash.
Okay, sure.
So
So
OA
we
dash
know this is perpendicular.
and the 9-point. Okay, it lies on the 9-point circle. Okay.
Hmm. Wait, also like some more stupid stuff, preliminary stuff that you should definitely write in an exam even if you don't write anything else. Like FDE plus FTE is 180, guys. Groundbreaking discovery. Hmm. Wait, do we know any of these angles? Yeah, we know FD, right?
FDES twice 2A. 180 minus 2A, then
Yes. So angle FTE seems to be neat. It's 180 minus 2A.
Uh,
Oh, do we get 2A anywhere else in this?
center. BOC is 2A.
how
Interesting.
did we get
Angle
FT
B.
equals 180 minus 2A?
Oh, because FDE is 2A.
Oh,
That's why. And
uh,
angle BOC is also equal to 2A. Amazing.
Wait,
Hmm.
what's going on? What?
Interesting. So this angle is 2A. Can we sort of like get another? Okay, this is hard to see, but like
okay,
this
what
is.
about if we take the midpoints of AB and AC so that they would lie on the circle?
Hmm.
Like we were thinking of new midpoints, so
Right. So you'll get things on the circle. So let's call these B prime, C prime. Please bear with my beautiful drawing skills. We know this angle is 180 minus 2a. So, okay, this is also like FDE. And also notice that we haven't really used that FMT collinear, ENT collinear and stuff.
Yeah, because we never found a concrete way to like represent the midpoint of CD.
Yeah, that is very weird. So like we also know so we have something like this. We have DBC. This is the triangle DBC. And we have some 2A over here. We have these midpoints. And we have some angle over here, which is 180 minus 2A.
Or the intersection, like of those, like there's a cycle quadrilateral in the middle, right?
Sure.
But
But
that's
you just said something before that. What was like the statement you said before this? The midpoints, we are not able to figure out what to do with the midpoints. Can
yeah.
you figure out what to do with the midpoints based on this somehow? This is O.
Is O the midpoint of DT?
That I don't know. That is
What about
true.
DO rather?
What about DO?
The midpoint of DO.
The midpoint of DO, what will that achieve?
Like I
Let's
was
call it
thinking we could
simple.
get some cyclicity because that 180 minus 2a,
Hmm.
but not sure it helps. My diagram's getting too stuff.
Wait, my diagram is not that scuffed. I
What
think.
about midpoint of HO since it's the 9-point center? But that's useless. Okay, leave.
Okay.
Never mind, yes.
No, don't say that. That's what you thought with your ideas for the previous question. Look how well that turned out.
Okay, I think to prove collinearity, we should use some supplementary angle stuff. Using showing that the angles from maybe I don't know DOE and EOT, they add up to 180. I think we could use that because if we try
Hmm.
to take that and somehow kind of use the directed angles we know, then we could kind of
Hmm.
show that it is supplementary. Like it's one of the very
Hmm.
trivial ways.
Okay. Interesting.
What about parallelograms since we have midpoints?
Wait. Why did we rule out some of the things? Okay. I think we have so many ideas now. Maybe a good idea at this point is like try to examine every idea and sort of just say whether it's a yay or a nay to go ahead with. And try to see why it would be like a yay or a nay. Because we're just like piling up ideas and not really doing anything
Yeah,
with that.
using any.
Yeah, that
Okay. Yeah, that's okay. So which one do we look at first? Do you want to look at maybe the 9-point center? What happens if you look at the 9-point center?
Not
What?
much benefit, I thought. Because CD's
Hmm.
midpoint is not connected to the 9-point center.
True. CDBD midpoint. Yeah. So it's like the crucial part here is to somehow connect M and N with everything.
okay. Then
Okay.
we could
What?
take some circles of M and N using M and
Okay.
N.
Interesting.
Okay, so like
So
some
what
M
about
and T or something. Okay, what
M
about
and
M
T?
and T?
Okay. Okay. So we already know this angle is 180 minus 2A.
Yeah.
So
So if
that's a
we
good
show
idea. So
that
it means,
some other angle is 2A opposite to it.
hmm, hmm.
Okay, it's not
Hmm.
MDN. It's something between D and O. That should be like so like if we have some point on DO
Hmm.
and we want to show that point X is 2A. Okay, it's the midpoint. Oh, it's the midpoint of DO.
What is Ronald talking about, guys?
Okay. As I'll formulate. So
Huh.
what I was thinking was so that now we have MNT, the circumcircle of MNT, and we are already aware of this angle 180 minus 2A.
Amazing.
So now trying to kind of use another point which we know about to kind of get some cyclic quadrilaterals on that same circle.
Right.
So what I deduced is that point, suppose that point is x. So we must have
Okay.
mxn is equal to 2A, supplementary
Okay.
angles.
Yes.
And that x can't be D and it can't be further away
Right.
from O.
Right.
So it must be somewhere between that. And then if we took the midpoint of DO, I think that's satisfies it.
Why?
Because like if you take okay, maybe we can do some angle chase. Like it should lie on DO.
Interesting.
Okay, I think I can come up with some angle chase. Let me just
We just want any point we just want any point such that mxn equals to 2a.
So the claim here is that, I don't know how Ronald is cooking this claim, is that if you look at the midpoint of DO, call it X, then MXNT is cyclic.
How did we prove FD equals to 2a?
FD is 2A because D is the center of AFE. That's why. And D is the center of AFE because these two are 90 and it's the midpoint of AH.
Yes.
Yes. Hey guys, this is okay. It seems hard, no? Like, how would you relate midpoint of DO and like get it cyclic? I don't know.
Homocity around D, but
Yeah, exactly.
oh no, wait, angle chase, right? Midpoint theorem stuff, because
Yeah,
angle.
sure. Either way to look at it, like just think about homotherapy works, angle theory works. Like all you're doing is BOC, you're doing homotherapy to that with ratio 2, you'll get MXN. The angle is still the same.
You want
okay,
to
I think
prove D
okay, I
and T
think
are
I got
antipolar.
something.
Wait, so
right?
that solves.
We have not solved the question, like, but we still have we have cooked up some seemingly magical point which is like neat,
We want to
Yeah,
prove
yeah.
D
I
and
think
I guess.
I think I got something about that cyclicity.
So if we
So
consider midpoint of DO, call it X, then MXNT is cyclic.
yes, so
Huh.
the way how we show that is we know mxn is equal to BOC.
Yes.
Okay, we have shown that, and but uh, because of the fact that O is the circumcenter, we can show that
Exactly.
it's 2 BAC
Yes.
inscribed angles,
Indeed.
and now we are getting that BAC is equal to EDF, also trivial.
Yes.
2 BAC is equal to EDF.
Yes.
And now if we take the supplementary angle of that,
Hmm.
so EDF, so what did we show till now? MGN, angle MGN,
Hmm.
that MXN, that, okay, we're using different, okay, MXN is equal to EDF.
Hmm.
And now that is going to be equal to 180 minus ETF,
Yes.
supplementary
It's
angles.
just angle theory. Yeah, it's just angle theory.
Exactly. So that proves the cyclicity.
Okay, this has already made me quite happy. I don't know what people's happiness meter is right now, but I'm
Okay,
somewhere
mine
on
is
the
on
higher
full.
side.
Geo
Let's
makes me happy.
go. Let's go.
Hold on.
Okay. Is everybody on board with X and why it seems to be a nice point?
Or maybe we can clear some stuff out. So we have this cyclicity. We show that this is there. So what my main goal for cyclicity, why I was thinking this is because if we can now get some supplementary angles on to show that our 3 points are collinear,
Hmm.
that we could do it using our newfound point X.
Right. Let me do one thing. Just that there's a lot of clutter in the diagram. Let's eliminate some random things and make a new one. So we already have some point D here, which is like the center of something, which is like EF. There's some point here, which is T. There is somewhere over here, there is M. There is somewhere over here, there is N. And somewhere here you have O, and you have midpoint of this, then you have X here somewhere. And you also have like these are cyclic as well, is what you have. So this is also cyclic, is what you have.
With
And what
DEFT
you
is also
would,
cyclic by itself.
yes, that is given, right? DEFT cyclic is given.
Yes. Okay.
And you also know MXTN cyclic, which is quite neat. And what you want to show is that DXO. We already know DXO collinear because that's how we define things. What you want to show is DXOT. T also lies on this line is what you want to show. So
Okay, so now we have to
we
use that angle, that point T. So what would that midpoint help us? How would that help us?
right. So let
Homotherapy?
me just join DT. Interesting. Let me join DT. What do you know about DT in this cyclic quadrilateral, DETF?
Okay, so it's obviously
Angle.
a kite. It looks like
It's
it.
angle bisector.
Angle
Yes,
by
because
Okay,
these two
yeah.
are equal. And
Wait, is
what
MX
would be
equal to MN?
nice?
Oh yeah,
Huh?
it is MX equal to XN. Yes. MX equal
So
to
Oh
XN
D
my
is
because
the
God.
midpoint.
BOCO.
So yeah, so D is the
Let's
midpoint
go. So
of
these
the
are
Another
also
axis of the
definition.
equal.
circle.
Let's go. Yes.
We finished.
Amazing.
how is MX equal to XN?
MX equal to half
Yes.
BO, XN equal to half CO.
The whole point was
Yes.
just angle chasing and cyclic chords.
Yes. So MX is half of BO, and because of the definition. So I sincerely apologize for my amazingly drawn diagrams, but MX is half BO by midpoint theorem. And NX is half
Ah.
CO, but CO is equal to BO. So XM is equal to XM. So TX bisects this angle and DT also bisects this angle.
It
So we
feels
must
so
have that
happy.
TX and DT. I know.
It feels
So
happy
like,
when your hypothesis is right.
let's
Like
go.
whenever I see collinearity, it feels like those angles.
Let's go. This is like, how happy are people feeling about this on a scale of 1 to 10?
Okay, don't ask me.
Your meter is broken.
Yeah.
This is quite neat. I found like again like introducing this point X is like so magical and just like feels like it's like dropping from the clouds. Like how do you think of this X? It's quite nice it is. Hopefully
This
it
is by
doesn't
the
feel
teachings of
like
Om. This is by the teachings
yes.
of Om.
So true. Om sir has been called. We shall ping him after class. Okay.
But what problem was
Any
this?
yes, this is actually EGM mode India TST 2024 P6.
Oh, cool. Yeah. Okay, now that raised it even more.
Yes.
That happens. But
There is actually a complex dash solution to this on the AOPS thread. I think Nanda has put it up. So you can check it out if you're interested. But this solution I found it made me quite happy. So it's a happy solution, guys. Wait, is everybody on board with this? Yay, nay, maybe, I don't know.
yeah.
DF equals to FE.
Okay.
How did we get
DF equal to
FE?
DE, that's because DF is equal to DE because D is the center of
Circle.
AF.
Yeah.
Yes. Amazing. Okay. No, that has made me so sad. Okay, it's
Come on,
fine.
Nishant. It's Geo.
All right,
Good.
let's do another. Let's end with something. Which one should we do? Okay, maybe I'll show you the list of problems that I had in mind and you can pick one. Uh, how do I reshare? I need to reshare. Yeah. So we already did the first two. Those were like the main ones that I really, really wanted to talk about. These are also some really good ones. Is there anything in particular that you want to do? Yes, also like there is an unique here, guys.
Fine, we can look at the unique.
That's cool. Okay.
I mean, not that I like algebra, but
No, like okay, algebra is most of the times good, but I struggle with inequalities quite a bit. But this inequality is still here, like on the list of my happy problems. So wait, why is it so small? Hang on. I think this was there in mock also we had put it. I remember correctly. But yes. Okay, let's do this. Any ideas about what we could do?
1 minus p divides 1 minus p to the power m. Oh, wait,
Okay, interesting.
is that true?
So, I mean, how would you work with divides here? Because now p is a real number.
No, 1 minus p into something is 1 minus p to the power m. So 1 minus p becomes q.
Yes. Okay.
1 minus p
Okay.
becomes q.
Okay, I think we need to do some binomial things.
Some binomial things. Okay. Okay. Interesting.
Substituting for p
Have you ever seen P and Q in an inequality before?
Holders, I
in
don't know.
primes, in prime inequalities, yeah.
Damn, you see prime inequalities. Like what inequalities are you dealing with? Okay. No, like in an actual inequality. Does P and Q ever come up? I don't know. Like P and Q is more like it's more like a prime thing or like a probability sort of a thing, if you know what I'm
I
talking
think
about. No?
I've seen it somewhere in some special case of like holders or something. All the
Maybe,
names are mixing me up.
maybe. This does seem like okay. I have actually like no clue whatsoever how to motivate this, but P and Q seem like probability type variables, and they
Yeah,
are
like if you could have
conveniently
a
adding up to one.
yeah, that itself is motivation, yeah.
Hmm.
Sure.
Not really. Like there's so many inequality problems where they give you like this addition to be something weird and stuff.
One,
So
yeah.
that is yeah.
But it's giving you
yeah, that
one,
is
so
Complementary events,
hmm.
or do you call it complementary events now?
yeah.
Hmm. So now the problem is purely combinatorial. If that's
Okay,
and that's also
so
nice for us because M and N are just M and N are integers, positive integers in fact. So that is very happy.
The
That is
so
chances
fine.
of
MNN could give us like it could be like the number of rounds we do something.
Hmm.
yeah.
So suppose we do an
basically,
event like roll a die. So M could be the number of times you roll that and get P. Okay, suppose we have a weighted coin because we don't know what P and Q are.
Hmm.
So then
Hmm.
we could think that the number of times you flip the coin, suppose you do it M times. So that could give you something
Hmm.
with P of M and the same thing for Q.
Hmm. Hmm.
yeah, so isn't this basically the chance that if you have a MXN grid and you color it
So you
black,
consider an M by N grid.
no,
Hmm.
uh, like we have no zero column or no zero row, no one row, and those are mutually
Be more
disjoint.
precise.
No column of
Yes.
zeros and no row of
No, what
ones.
is
I
zero
get
and one? Like what is zero and one? You're
black or white,
defining
whatever you want to call it. You have
Sure, but like
P chance of
where is that? Okay,
P
say
chance
that.
0, Q chance 1. Yeah,
Yeah,
whatever you want to
with
call it.
P probability P it's black, let's say, and with probability Q it's white.
And the good thing is that they are completely disjoint, right? So you can add them
So
normally.
yeah,
Because if there's a P row, there's no Q row, and vice versa.
yeah. And at least one of those two things have to happen. That's why it's at least one.
Hmm.
Okay, so if P is the chances you get a heads, just coming back to that thing, I was thinking about that. So if P was the
Hmm.
chances you get a heads,
Hmm.
then P to the power M over
Hmm.
P plus Q to the power M, which is just 1, is the chances that you get M consecutive heads.
Okay. P to the
And
power M is M heads. Okay.
okay, and then the 1 minus that would be that you have absolutely no chance of it occurring, almost.
Hmm.
And the same thing for Q, but we would use tails.
I had
Okay,
something.
interesting.
Okay.
So you also want to have something where you have to have something where you have something that you're
Oh,
taking M times, then that thing you're taking N times,
Yeah,
right? So
yeah.
this
Yeah,
is
yeah.
which
so
is what
yeah,
motivates this M by N grid that Shreyan had.
Right,
So I
yeah,
think
right. So
Nishant
1
also has
minus
the same.
yeah.
so 1
So
minus P
basically,
to the power M will become like the chances of
of no head,
of no
Consecutive
black or white,
heads.
no black or white in that row.
no
Yes.
black row.
So P to the
One.
M, P to the M is basically everything in this row being black, but 1 minus P to the M is like at least one white. It's
And
like
then
something
to the
that's
power
not
N
completely
means
black,
each white.
not fully
Wait, could you
black.
explain the kind of grid again?
So
What
why
is
can't
it
we just do
exactly?
Yes.
2? So we just take 2 minus we take 2 minus both sides, and we just want to show that this thing is smaller than or equal to 1. So basically, we want to construct a way so there's no black row and there is no white column. No, we
Yeah.
don't have to construct that. We don't even have to
No, no, no,
construct
no.
it.
You don't have to draw that. Yeah, yeah.
Yeah, exactly.
It's
Because it's
okay.
saying less than equal
Let's.
to. Yeah, so we are done.
Yeah.
That was
So
very.
what we have is okay. Yes, it's so. How happy are you about that, Sriyan?
Okay, I'm
Okay.
still stuck on understanding what the grid is
Yes,
about.
yes, yeah, yes. Let's do it. So do you see why it's motivated to consider an M by N grid?
Yeah, because you have eminent, yes.
Yes, and also you're doing something M times and then repeating that entire thing N times. So 1 minus P to
Exactly.
the M is the probability of a row which is like not being fully black. And that you're multiplying itself N times, which means that this is not fully black, this is not fully black, and so on and so forth until this is
Ooh,
not fully
yes.
black.
Yeah, I think I got it. Yeah, I got Shreyan's finish.
Yes. And then same thing you do with the columns. Now you 1 minus Q to the N is this is not fully white, and this is not fully white. Up until the end, and this is not fully white.
Oh, yes. Okay, now I see what. Oh, nice thinking. Yeah.
And so now, since at least one of these two events occurs, then you get that the sum is at least one. You cannot have that both of these events are, uh, yeah. I think that's the idea.
Means that at
Quite
least one of these
neat.
events must occur, right? That's how we should frame it.
Sure. The other thing Shreyan said is also fine. Like what you can do
Yeah,
is
I was thinking of Shreyan's way, so I didn't understand.
it's equivalent. Like you subtract two from both the things, and
Correct.
then you get some probability, which is like has to be at most one. So and all probabilities are.
Yeah.
And like there's more you have to be more careful with that. Like you have to show that. But yeah, it's definitely the only inequality which I would call my favorite maybe.
Yeah, because it's combinatorics, no algebra.
Yeah. Okay. But yeah, this is quite needed this. Okay. I think that's time. Unless you all want to stay back and do another question, we could do that, or we can stop here. I'm fine either way.
Yeah, doing one more works for me.
Yeah, I can stay.
Okay, let's do another one. Again, I'll show you the list if you want. Hmm. Okay, maybe let's not look at the last one. It'll take us a while. Maybe like either this one is quite weak. Let's do this one, guys. Dictatorship.
Okay.
I let you choose the last one. I will choose this. Why are you guys agreeing to me? Okay, sure.
It looks sweet.
So sweet. Okay.
Like, isn't that
Okay. Hmm. Okay, this is some ISL. Okay, wait, what was the source of this? Okay, no, there's no good. I just, I think it was on some mock that I gave somewhere at some point. Oh, let's finish this. I have to go soon. Let's quickly do this one. Okay. We have A naught less than A1 less than A2. And there should be a unique m such that an is less than right off the bat. Again, like noticing that things were weird is also like a big help. For example, in this, you notice that okay, this operation is seemingly quite weird. Can we make it less weird? But over here, m and n are quite weird. Can we sort of make them less weird by doing more weird things? So over here also we want to see, okay, what is like the weird thing here? What are the seemingly weird things here?
that it works for all possible sequences, and the
Unique.
sequences
The
itself
weird-
is
The weird thing is unique.
Maybe. But also like in this expression, is there anything weird?
Why is their average popping up greater than the other one?
It's not even average. That's the weird thing. Like it's not
Wait,
even
hold on.
average.
Why?
You're
No,
adding
wait, it's
n
not
plus.
average. Why is it A naught?
Yeah, A naught is
If
so
it,
annoying. A naught is quite good.
no, I mean, if it was average, it would be impossible for AN to be smaller. You have average of stuff which is smaller or
Yeah,
equal
yeah,
to
Yeah,
you need
right.
a thingy.
to balance it out.
Yeah.
Yeah.
Let's just do this, guys.
okay.
Okay. This is maybe slightly more nicer looking. I feel slightly better looking at this already.
You have to prove that there exists a unique positive integer or just integer.
Positive, like n is positive, right? N is positive.
Okay.
Unique integer n for which this is true.
Can you just subtract them from both sides? Like, so you basically have
N minus 1.
n minus a naught, an minus a naught plus an minus a1 plus an minus a2 plus da 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 da.
Da 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 da. Okay, so with
But
here
I
this
think we can do
becomes.
some induction here.
Wait. Let's try to see what Sriyan is saying. So you're saying this. Okay, one thing is like the A naught is very asymmetric. Even this from like its name, it's like very bad. Let's just keep it, and we will subtract everything else. And then, as Sriyan said, it's nicely working out because this is just the sum of an minus a1 plus an
Different.
minus a2 plus da 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 in Shreyan's words. This and what is over here?
an plus 1 wala.
Oh, exactly.
Hmm.
And this is just a function of an plus 1. This is just a function of n, right?
Yes, indeed.
And basically you have a function of n, and you just want to prove that it's strictly increasing, and we are done. You want to prove that there is a solution, and we want to prove it's strictly increasing. And it's strictly
Indeed,
increasing
yes.
for relatively easy to see reasons.
Yes.
Wait, coming back to the question, was A not given? No, right?
And we just want to show that the possible
Yes,
answer.
yes. I mean, it's some infinite sequence of positive integers, so it's like fixed.
And it says it's positive integer. So this thing, the function is getting arbitrarily high values.
Yeah, so
Indeed.
And we just have to show that
continuous.
if a0, and we just want to show a0 does not work. Right, n equal to
Yes.
0, I mean n equals to 1, either is, yeah, then we should be done. Yeah, that is a1 smaller than a0 plus a1 smaller than 8.
No, you just
Uh,
for For n equal to 1, you just want a1 smaller than a0, right?
A1, yeah, and then we are done. No, something along those lines.
I mean, we don't want a1 smaller than a0. I mean, sorry, we don't want a1 smaller than a0, which means we want a0 plus equal a1, which is true, which
And
is given to us.
Yeah, so
Okay,
I mean
suppose
the
we
edge
take the
cases can be worked out.
differences. Yeah.
Huh?
The edge cases can be worked out. It's not a big deal, I think.
Yeah,
Yeah,
that is, yeah. It's not a
Okay.
big deal, yeah.
yes.
Okay, suppose we take the difference between two consecutive terms in the sequence. So like AK and AK plus 1, the difference is
Mm-hmm.
DK.
Mm-hmm.
So then we could show, we could kind of express both the left side and the right side of our inequality in terms of a summation of dn.
Sure. You can do that as well. You know, like the intuitive idea is that this summation, like the way to look at this summation is basically take your number, look at its difference between with everything smaller than it, and just add up all these differences. Same thing, and that's what you're doing here and here as well. So, and this is a constant, this is not changing. The only thing that are changing is this and this. So, and this quantity, this sort of a function where you take a number, look at everything smaller than it, and add up all of these things, this is increasing. So
Yes.
at some point you will have a naught in between these two. That's the idea.
Yeah, that's it. Okay, this is nice. Fine.
Okay. I hope your happiness meter has gone thoda positive. Okay. Yes, I have to go. But yes, I hope this was fun because
Could you like
I
send the whatever?
I'll actually I'm thinking of eventually like compiling all these problems and maybe like putting it up as a piece set or maybe a handout or some sort. So
And
we'll do
also
it.
one more thing, like the classes of like
Huh.
2-3 weeks back haven't been uploaded on YouTube. Like I was present for one
Yes.
class, but I want to like check something, so I was waiting for
Oh,
it.
which class are you talking about?
Anant's class, like he took
Oh,
one on
that was
2
not
weeks ago.
recorded. That want to be put up.
Oh,
That was not
okay.
recorded. Yeah.
Oh, it's fine. Then the ones after that, if they were, I missed the group.
Yeah. Yes, we will put that up soon. Sorry about the delay in that.